Bring your study guide. Bring your study guide tomorrow, class. Be ready to work on it. Identify the derivatives of the following functions. Derivative of sine is cosine. You see, yesterday you learned that. That was really important. Now you might think the derivative then of cosine is, except it's negative sine of x. The derivative of tangent is secant squared of x. The derivative of cosecant of x happens to be negative cosecant of x cotangent of x. The derivative of secant of x happens to be secant of x times tangent of x. And the derivative of cotangent of x happens to be negative cosecant squared of x. You do need to have these memorized. Okay. Some people wonder, how do you ever begin to memorize these things? And I will tell you that I do a bad job of helping you get there. Let's go to work and find some derivatives. Derive the following. F of x equal to negative 4 plus a tangent of x. I want to find f prime of x. What is the derivative of negative 4x? Negative 4. What is the derivative of tangent of x? Secant squared of x. That's it. Look at the next one, f prime of x. What's the derivative of sine of x? So therefore, the derivative of 3 sine of x would be 3 cosine. You see, if you have a constant, it just comes along for the ride. Okay? So then what do you think I have? Minus 4 cosine of x, or 4 sine of x. Good job. What's different about the next one? There is an x in front. What do you think we do if we have an x in front? Let's read it off. It says 3x plus x times cotangent of x. The product rule. Okay, so remember we practiced the product rule earlier and the quotient rule? Those are going to be two things that you're going to use throughout the rest of the year, and this is a time where we'll continue to use it. So I have f prime of x is equal to, the derivative of 3x is just 3, but then for x cotangent of x, what I have here is, I'm going to call this f, and I'm going to call this g. And remember that the derivative, using the product rule, is f prime g plus g prime f. So I just leave the 3 off to the side, plus, what's the derivative of x? 1 times cotangent of x. Plus, what's the derivative of cotangent? Negative cosecant squared of x times x. I would appreciate it at this point if you rewrote it, 3 plus cotangent of x, and then it will be minus, and traditionally we do put the polynomial term, this x, we do put it in front so it's not confused with the other x. So minus x cosecant squared of x. And if you look at your original problem, that will tell you as well. Okay. All right. What rule do you think we should do for letter D? We would say the quotient rule, and I'm going to tell you, not so fast. Please just use a little bit of basic understanding of trigonometry and just start by rewriting it. What is 2 over cosine? It's the same as 2 times. What is 1 over cosine? It's the same as secant. This is 2 secant. I would much rather take the derivative of 2 secant of x plus 3 than use the quotient rule here. And so as I take the derivative, f prime of x, what is the derivative of 2 secant? 2 secant of x, tangent of x, and then the derivative of 3 is 0. So in that situation, you can rewrite it so that you don't have to use the quotient rule. And I encourage you to do so. Sir? No, it's all multiplication. If the derivative was secant of x plus tangent of x, then you would distribute the 2 through. Okay, question. I will end your e-hall pass. We should probably pause the video. We don't. Okay. With letter E, there's no way to rewrite this. We simply need to use the quotient rule. At that point, pause, slow down, be careful, and take your time. Don't cry because it's math, and math is beautiful. So we have f prime of x is equal to, I take the derivative of the top. What is the derivative of the top? Cosine of x times x plus cosine of x. Then what? Minus the derivative of the bottom. 1 minus sine squared. 1 minus, just 1 minus sine. What is it? 1 minus sine of x times 1 plus sine of x. All over x plus cosine of x, quantity squared. Oh my goodness. How do we know when we're done? We know when we're done when we are combined like terms and simplified any trigonometric expressions that we can. So I'm going to distribute. Do you see some terms that will combine here? Maybe, maybe not. F prime of x is x cosine of x plus what? Cosine squared of x. Does anybody know what you're going to get when you take 1 minus sine of x times 1 plus sine of x? Everybody see you get 1 minus sine squared? So I'm going to subtract that. So it's going to be a minus 1 and then what? Plus sine squared of x. All over x plus cosine of x quantity squared. At this point, you have to see it. I can't see it for you. I can only show you and hope that you see it over time. Sine squared plus cosine squared is 1. So that becomes 1, and then 1 minus 1 will give me 0. So you can see that whole business goes away. F prime of x is then equal to x cosine of x over x plus cosine of x, quantity squared in the denominator. You can see that the problems range from a little bit more challenging, which we just did, to the very beginning one was quite easy, correct? So you can see your assignment will present that challenge. We try letter F. What rule would you like to use in this situation? The product rule. I agree. What a great option. This is not written correctly. This should say f of theta is equal to secant of theta times theta plus tangent of theta. Sorry about that. So this tells us the variable that we are using. Suppose it's y equals. What variable do you think you would be using then? You're going to usually have x pop up. If there was another, say there was another variable in here, like say a or b or something like that, you would just treat that as a constant. You'll see some of that in your homework today, and you'll be able to work through it. So I have f prime of theta. This can get a little bit lengthy. F prime of theta is, what's the derivative of secant? Secant of theta, tangent of theta. Okay, times theta plus tangent of theta. Plus, yeah, so now Asher is taking the derivative of theta plus tangent of theta. The derivative of theta is 1. The derivative of tangent of theta is secant squared of theta. times secant of theta. Oh boy. That's a lot of thetas and secants and tangents. I'm going to distribute it through to see if something connects there. Looks like I'm going to have a theta, secant of theta, tangent of theta. So I just distributed this to the theta. What am I going to have after that? Yep, secant of theta times tangent squared of theta. What then? Plus secant of theta plus secant cubed of theta. So, you know, as you're looking to see if something cancels, we could factor out a secant, couldn't we? And that doesn't necessarily simplify it, but if we did factor out a secant theta, you would get a tangent squared and a secant squared. Does a tangent squared plus a secant squared, does a tangent squared plus a secant squared amount to anything? No, you'd have to have tangent squared minus secant squared, wouldn't you? So really, we're done. You know, we're done at this point. So just kind of looks ugly. But that's the derivative. Now, as soon as you complain about it, I just want you to think about this. Suppose, instead, you had to do a plus h, or x plus h instead. Suppose you had to do the formal definition. That would be pretty difficult, right? So all that work we did yesterday amounted to the fact where we could just say these derivatives are what they are. We proved sine yesterday, and we will do a different proof today. We have 2 problems left. The proof is simple today. You won't have any problem with it, but let's get back to the basic question, which is write an equation for line tangent. If you need an equation for line tangent, what are the 2 things you need? Slope and a point on the line. Well, the point on the line, it looks like it happens at pi over 6. And so I'm now going to need the y value. So I'm going to plug pi over 6 in. 1 minus sine of pi over 6. Pi over 6 is how many degrees, folks? 30 degrees. So if I make my 30, 60, 90 triangle, hypotenuse of 1 in the unit circle, you all remember what the coordinate is there, don't you? What is my terminal point? Root of 3 over 2. And what's the y value? 1/2. Very good. Is the sine value the y value or the x value? It is the y value. So if you plug in pi over 6 for sine, you get 1/2. What's 1 minus 1/2? 1/2. Slope. How do I determine slope? The derivative. When in doubt, take the derivative. F prime of x is equal to derivative of 1, 0. Derivative of negative sine of x. Negative cosine of x. What do I plug in to find the slope then? Where am I trying to find the slope at? Pi over 6. So you plug in pi over 6. So the cosine of pi over 6, hey, I already have pi over 6 drawn here, 30 degrees drawn. Is cosine the x value or the y value? It's the x value. So therefore, we can now use this one for the slope. Isn't that handy? Negative root of 3 over 2 is the slope. Y minus y1 is equal to m, negative root of 3 over 2, times x minus x1. On the AP exam, you can leave the line in that form. In this class, you do have to write it in the slope-intercept form as best as you can. We'll show how that works here. Y minus 1/2 is equal to negative root of 3 over 2x plus pi roots of 3 over what? Pi roots of 3 over 12. And then I'm going to add the 1/2 to both sides. So y is equal to negative root of 3 over 2x. And as we add the 1/2, we add 6/12. So plus pi roots of 3 plus 6 over 12. So that's my slope. That's my y-intercept. It looks ugly. That would be actually a very excellent AP exam question. That's the type of question that you're going to see. So, last example, proofs. Here we go. Prove that the derivative of cosecant is negative cosecant cotangent. Yesterday we proved that the derivative of sine was cosine. So today we're going to prove this one using our results from yesterday. So, here's what we have. The derivative of cosecant of x is the same thing as the derivative of 1 over sine of x. Everybody okay with that step? I will use the quotient rule. What's the derivative of the top? What's the derivative of a constant? 0 times the bottom left alone. What is the derivative of the bottom? Times the top left alone. All divided by the bottom squared. Everybody okay with setting up that quotient rule? Then what am I left with on the top? Negative cosine of x. And on the bottom? Sine squared of x. Well, somehow I have to get from there to here. Does everybody see that? So just look at what you need to come up with and see if we have it there, okay? Well, what is negative cosecant? Negative cosecant is the same as negative 1 over sine. So I'm going to write negative 1 over sine of x times, if I take out a negative 1 over sine of x from this expression right here, what remains? Cosine over sine. Does that give me what I need? Is cotangent the same as cosine over sine? Yeah, so we see that you have negative cosecant of x times cotangent of x. Done, box, QED, whatever you want to do, you have proved that what you set out to do. Proof, nice and short, no big deal. We leave this for another day, which would be next week, Monday.